In this video, we will derive the equations of motion by graphical method. Here we will derive v is equals u plus at, s equals ut plus half at square, and v square is equals u square plus 2as using graphical method. So let's start. First of all, let us consider an object moving along a straight line path with initial velocity u and uniform acceleration a. Suppose it travels a distance s in time t. So as shown in this figure, this is a velocity time graph and it represents the motion of the particle. So the velocity time graph for the motion of the particle will be a straight line where u is the initial velocity and v is the final velocity. So from this graph, OA is equals ED. OA is equals ED, and that is our initial velocity u. And OC is equals EB. That is our final velocity v. And OE is equals AD. That is our time t. So the object is moving along a straight line path. So the object is moving along a straight line path with initial velocity u and acceleration a, and it travels a distance s in time t. Now let's find the acceleration. So we can find the acceleration from this velocity time graph. How can we find? We have to find the slope of this curve. So slope of AB from this velocity time graph will give us the acceleration. And slope of AB is perpendicular by base, that is BD by AD. Now BD can be written as EB minus ED. EB minus ED. And let's write AD as OE. We can write AD as OE. So our EB was V. EB was V. And ED was the initial velocity u. And OE is our time t. And acceleration is a. So we can write, if we cross multiply it, it will be v minus u is equals at. So we will get v is equals u plus at. So this is our first equation of motion. This is our first equation of motion. Now we get acceleration dB by AD from the part 1. Acceleration dB by AD. And dB was, let's write dB as it is, and AD was our time t. AD was our time t. So dB is equals AT. Let's keep it as it is. Now if we want to find the distance traveled by the object from this velocity time graph, then we have to find the area under this curve. To find the distance traveled by the object from this velocity time graph, we have to find the area under this curve. So distance traveled by the object in time t is area of the trapezium OABE. So the area will be OABE, and this is a trapezium, right? So we have to find the area under this curve. And then we can break the trapezium into triangle and a rectangle, right? So area of rectangle OADE plus area of triangle ADB. Let's do this. Distance traveled by the object in time t is equals area of trapezium OABE, and that can be written as area of rectangle OADE plus area of triangle ADB. So area of trapezium OABE can be written as area of rectangle OAD plus area of triangle ADB. So area of rectangle OAD will be OA times OE. OA times OE. OA times OE. Plus area of triangle ADB will be half into AD into BD. Half into AD into BD. Let's put all the values. So our OA was initial velocity u and OE was time t plus half. AD is our t and BD is our AT. BD is our AT. So it will be S is equals UT plus half AT square. So this is our second equation of motion, S equals UT plus half AT square. Now last we have to find V square equals U square plus 2AS. Now for this, let's again find the distance traveled, that is S equals area of trapezium OABE, right? Area of trapezium is half into length of the parallel sides, that is EB plus OA, into distance between them, that is OE. So let's put now half EB, OA can be written as ED into OE. Let's name this as equation 1. Now acceleration, again acceleration is dB by AD. Acceleration is dB by AD. And dB can be written as EB minus ED by OE. AD can be written as OE. Then in the next step, let's write OE is equals EB minus ED by A. Now let's put the value of OE into this. Therefore, S is equals half EB plus ED times EB minus ED by A. Now this is nothing but A plus B into A minus B, that is it will be A square minus B square. So 1 by 2A EB square minus ED square, that is 1 by 2A. EB square is nothing but our B, that is B square, and ED square is our U square. So we get B square minus U square is equals 2AS. This is our third equation of motion. Thanks for watching.